Hello, friends. We're continuing our study of geometry, and today we're going to be looking again at logic statements and truth tables and that sort of thing. So we start off where we have been before with the conditional. If P, then Q, right? Or P implies Q. That's the symbolism for it. An example: if today is Tuesday, tomorrow is Wednesday. That would be an example of a conditional statement. Converse, if tomorrow is Wednesday, today is Tuesday. Remember the converse, we switch. And those are not necessarily logically equivalent. Remember, so for example, the example I give later, if an animal is a dog, then it's a mammal, right? That's true. But if an animal is a mammal, then it's a dog. That's not necessarily true, right? So converses are not necessarily the same truth value as the initial original conditional statement. But today we're going to put them together. So the inverse and the converse, that together is what we call a biconditional. Okay, so it's bi meaning two, so two conditionals together. And that's if P, then Q, and if Q, then P. Or P implies Q and Q implies P. It's all of it together kind of as one statement. The symbol for it is the double arrow. P, and then what we say for this is if and only if. So what we say is if today is Tuesday, tomorrow is Wednesday. And if tomorrow is Wednesday, today is Tuesday. Or today is Tuesday if and only if tomorrow is Wednesday. And this is the symbol, again, the double arrow for the biconditional. Another way of writing this is today is Tuesday. The IFF is if and only if tomorrow is Wednesday. Like I've said before, mathematicians are lazy. We like to do things that, these are all shortcuts. Again, all of math symbols, those are shortcuts. Instead of writing out whole sentences and things, we have these symbols that allow us to do things quickly and compactly in an orderly kind of way. And so IFF, that's an accepted convention for if and only if. And again, the symbol for it is the double arrow. Okay, so here's an example of what we've seen before, a conditional truth table, right? If an animal is a dog, then it's a mammal. And so this type of statement is true all the time unless the hypothesis is true and the conclusion is false. Okay, so this is what the truth table looks like for the original conditional statement. For the converse, it looks different, right? Because now it's if Q, then P. Again, the only time this is false is when this part is true and this part is false. The only line where that happens is this, where this is true, right? This is the Q part, and then this is false. That's the P. And so this is the truth table for the converse of the original conditional statement. Okay, now we put them together. The biconditional is true only when both are true, right? So here's the original conditional, true, false, true, true. And then here is the converse, true, true, false, true. Okay, so the first line and the last line are the only ones where both statements are true. And so this is what the truth table looks like for a biconditional. Okay. But yeah, so let's look at this then. Go back to the biconditional. What does that mean? It means that an animal is a dog if and only if it is a mammal. In the case of a dog, right? The dog is a mammal, so it's true, it is a mammal. But if you have something like a cat, right? In that case, it's a mammal, but it's not a dog, and so that makes the conditional or the converse false. Um, and so it's not true that an animal is a dog if and only if it is a mammal. And so that puts us into this category right here, this line, if you have something like a cat. Right. So it all kind of works out. You think about it logically, but the truth tables can get a little bit confusing, but you follow the patterns. You learn the truth tables for the different kinds of statements that we have. Speaking of different types of statements, we're going to introduce compound statements. So compound statements are where there's an and or an or. So for example, P and Q, P or Q. An example would be today is Tuesday and tomorrow is Tuesday. You know, that can't be true. Or today is Tuesday or tomorrow is Tuesday. So if you think about it, this one can't be true. They can't both be true at the same time. Anytime you have an and statement, the only time it's true is when both things are true. When you have an or statement, it's true when either one is true. Or statements are called disjunctions. So here's the truth table for a disjunction. P or Q, and this is the symbol. It's like a V, right? So P or Q. I think of that as like a fork. It can go either this or this. And so if they're both true, it's true. If either one of them is true, it's true. The only time it's false is when both of the statements are false. Um, Kind of a joke that goes along with this I heard once. It's kind of a nerd joke. A uh, a logician's wife was giving birth, and the baby came out, and the wife asked the logician, "Is it a boy or a girl?" And the logician said, "Yes," because one or the other is true. So if you ask an or statement, then if either of them is true, then the outcome is true, right? The compound statement together. Okay, and then a conjunction is an and statement. So P and Q. The only time this is true is when both the uh, both P and Q are true. So, for example, if I say today is Tuesday and it's sunny, right now it is Tuesday, but it's not sunny. So the statement as a whole is considered false. Okay, and this is the symbol for it. I think of this as like two things together, right? We're joining these two things, and right, as opposed to the other one, the V, it's like this or this. If that helps you remember, that's great. And so what we learned today, biconditionals, and then also conjunctions and disjunctions. So thanks for watching. Don't forget to like and subscribe.